Hey, sixth graders, we are reviewing for the test. This will actually be your last assignment in quarter two. So let's get started. Okay, there we go. So geocentric is an Earth-centered model. Heliocentric is Earth and the other planets revolve around the sun, or a sun-centered model. An ellipse, remember, is the shape of what the planets move around the sun. That's an oval shape. The solar system, the system consisting of the sun and the planets and other objects that revolve around it. An astronomical unit is a unit of distance equal to the average distance between Earth and the sun, which is about 150 million kilometers. A planet is an object that orbits a star. It's large enough to have become rounded by its own gravity and has cleared the area of its orbit. A dwarf planet is an object that orbits the sun and has enough gravity to be spherical, but has not cleared the area of its orbit. Planetesimals are one of the small asteroid-like bodies that forms the building blocks of the planets. Core is the central region of the sun where nuclear fusion takes place. Nuclear fusion is the process in which two atomic nuclei combine to form a larger nucleus, forming a heavier element and releasing huge amounts of energy, the process by which energy is produced in the stars. Radiation zone is a region of very tightly packed gas in the sun's interior where energy is transferred mainly in the form of electromagnetic radiation. The photosphere is the inner layer of the sun's atmosphere that gives off its visible light, and that's also the sun's surface. The chromosphere is the middle layer of the sun's atmosphere. Corona is the outer layer of the sun where nuclear fusion takes place. And solar wind is a stream of electrically charged particles that emanate from the sun's corona. Next, we have sunspots, which are a dark area of gas on the sun's surface that is cooler than surrounding gases. Prominences, a huge reddish loop of gas that protrudes from the sun's surface, linking parts of sunspot regions. Solar flares are an eruption of gas from the sun's surface that occurs when the loops in sunspot regions suddenly connect. Next, we have the terrestrial planets, which is the name often given to the four inner planets, Mercury, Venus, Earth, and Mars. The greenhouse effect is the trapping of heat near a planet's surface by certain gases in the planet's atmosphere. Next, we have the gas giants, which is the name often given to the outer planets, which are Jupiter, Saturn, Uranus, and Neptune. A ring is a thin disk of small ice and rock particles surrounding a planet. And the asteroid belt is the region of the solar system between the orbits of Mars and Jupiter, where many asteroids are found. The Kuiper belt is a region where many small objects orbit the sun, and that stretches from beyond the orbit of Neptune to about 100 times Earth's distance from the sun. Excuse me. The Oort cloud, a spherical region of comets that surrounds the solar system. Comets are a loose collection of ice and dust that orbit the sun, typically in a long, narrow orbit. Coma is the fuzzy outer layer of a comet. The nucleus is the solid core of a comet. Asteroids, one of the rocky objects revolving around the sun that are too small and numerous to be considered planets. Meteoroids are a chunk of rock or dust in space, generally smaller than an asteroid. And our last two vocab words, meteor is a streak of light in the sky produced by the burning of a meteoroid in Earth's atmosphere, and meteorites, a meteoroid that passes through the atmosphere and hits Earth's surface. So, what from lesson 1? In a geocentric model, Earth is at the center of the revolving planets and stars. Copernicus was able to work out the arrangement of the known planets and how they move around the sun. After years of detailed calculations, Kepler found that the orbit of each planet is an ellipse, remember that oval shape. And then, however, evidence collected by the Italian scientist Galileo Galilei gradually convinced others that the heliocentric model the heliocentric model was correct. So remember, that's the one where everything revolves around the sun. And that is how our solar system is set up. So Ptolemy, a Greek astronomer, further developed the geocentric model. And make sure you're noting what each person is famous for, because that will be on the test. So Ptolemy published his work in 1543. His theory would eventually revolutionize the science of astronomy. Ptolemy and Copernicus both assumed that planets moved in perfect circles. Tycho Brahe made much more accurate observations, and Johannes Kepler used those observations to figure out the shapes. In 1610, Galileo used a telescope to discover 4 moons around Jupiter. This proved that not everything revolved around Earth, and he discovered Venus goes through phases, which are similar to the moons. He reasoned the geocentric model must be incorrect. Lesson 2, our solar system consists of the sun, the planets, their moons, and a variety of smaller objects. Scientists think the solar system formed about 4.6 billion years ago from a cloud of hydrogen, helium, rock, ice, and other materials pulled together by gravity. But remember, we know that God created the world as it was when we learned about that in creation. Satellites, except for Mercury and Venus, every planet has at least one satellite or moon. That will be on your test. Lesson 3, the sun has an interior and an atmosphere. The interior includes the core, the radiation zone, and the convection zone. The sun's atmosphere includes the photosphere, the chromosphere, and the corona. Features on or just above the sun's surface include sunspots, prominences, and solar flares. That last point will be on your test also. 2 of those words are used as vocabulary words, and then one of them is a word you're asked to identify that's about our sun's surface, the sun's surface. Lesson 4, the inner planets are small and dense and have rocky surfaces. Mercury is the smallest terrestrial planet and the planet closest to the sun. Venus has a thick atmosphere, an unusual pattern of rotation, and the hottest surface of any planet. Earth has liquid water and a suitable temperature range and atmosphere for living things to survive. Though Mars is mostly too cold for liquid water, it does have water ice now and shows evidence of intermittent seasonal flowing water today, as well as liquid water in the past. So remember those key things about each planet, because those will be on the test too. Mercury has flat plains and craters on its surface. No water, its mass is small, weak gravity, virtually no atmosphere. Venus's atmosphere is so thick that it is always cloudy. It's considered Earth's twin, and the pressure of Venus's atmosphere is 90 times that of Earth. Earth, about 70% of its surface is covered with water. Having water makes Earth unique, and if it were a little closer to the sun, the water would evaporate. If it were further away, the water would freeze. So that would be bad because then we wouldn't have any water to drink. And that's the only planet with an atmosphere rich in oxygen. Mars, the atmosphere is 95% or more carbon dioxide. Temperatures on the surface range from negative 140 degrees Celsius to 200 degrees Celsius, or 20 degrees Celsius, Some regions have volcanoes, and it has 2 very small moons, Phobos and Deimos. The outer planets, from lesson 5, the 4 outer planets are much larger and more massive than Earth, but they do not have solid surfaces. Jupiter is the largest and most massive planet. Saturn has the most spectacular rings of any planet. Uranus's axis of rotation is tilted at an angle of about 90 degrees from the vertical. Neptune is a cold blue planet. Its atmosphere contains visible clouds. Jupiter and Saturn are composed mainly of hydrogen and helium. Uranus and Neptune contain some of those, but also ices of ammonia and methane. Remember, Jupiter has that great red spot, a storm that is larger than Earth, and its moons are Ganymede, Callisto, Io, and Europa. Those are the big ones. Saturn's big moons, Titan, Mimas, Tethys, Enceladus, Phoebe, and Iapetus. Uranus is twice as far from the sun as Saturn. Viewed from Earth, it looks like it rotates from top to bottom instead of from side to side. Remember, Neptune had that great dark spot, but it disappeared 5 years after being discovered. It has 13 plus moons, the largest being Triton. And last, lesson 6, scientists classify these objects based on the sizes, shapes, compositions, and orbits. The major categories include dwarf planets, comets, asteroids, and meteoroids. Dwarf planets are Pluto, Aries, Makemake, Haumea, and Ceres as of 2009. Typically small, less than a kilometer in diameter. Ceres, Pallas, Vesta, Hygiea are more than 300 kilometers across. Those are the asteroids. Remember, Ceres is both a dwarf planet and the largest asteroid. And also to note, we talked about this in the lesson, but reminder, Pluto was at one point considered a planet. Now it is a dwarf planet. So that will also be on your test, so remember that. So that's it. Make sure you go check something out if you have questions or want to review something. Otherwise, your assignment for Thursday is the Chapter 5 test on Edmodo. Also, make sure that you're getting caught up because everything is due by Friday. That's the end of the quarter. So let me know if you have any questions or if there's anything I can do to help.